AMD has spent years watching from the sidelines while Nvidia dominated the AI chip market so completely that it seemed untouchable. In Q2 2025, Nvidia controlled a staggering 94% of the GPU market share. AMD just 6%, and that number was actually shrinking, down from 8% the previous year. Every major AI company, from OpenAI to Google to Meta, ran their operations almost entirely on Nvidia hardware. The gap wasn't just wide, it was expanding. AMD wasn't even considered a serious competitor anymore, relegated to being little more than a footnote in the AI revolution's history books. Then something unprecedented happened. OpenAI, the company behind ChatGPT and the most influential player in artificial intelligence, just signed a massive infrastructure deal, but not with Nvidia, with AMD, a deal potentially worth up to $100 billion that includes OpenAI receiving warrants for up to 10% of AMD's entire company. Within days of the announcement, AMD's stock price exploded upward by over 70%. Wall Street is calling it one of the most shocking partnerships in tech history. So what changed? How did AMD go from irrelevant to suddenly threatening Nvidia's iron grip on AI computing? And more importantly, is this the beginning of the end for Nvidia's monopoly, or is AMD making a desperate gamble that could backfire spectacularly? To understand why this deal matters so much, you first need to understand why AMD fell so catastrophically far behind Nvidia in the first place. Both companies made GPUs, right? So why did the entire AI industry flock to Nvidia while essentially ignoring AMD? The answer comes down to one word that changed everything: CUDA. CUDA stands for Compute Unified Device Architecture, and it sounds technical because it is. But this single software platform became Nvidia's unbreakable moat, the competitive advantage that locked customers in for over a decade. AMD's GPUs were actually quite good from a hardware perspective. Their Radeon graphics cards were used in some machine learning applications and performed respectably, but they had nothing remotely comparable to CUDA's comprehensive software ecosystem. CUDA is a powerful application programming interface specifically designed for NVIDIA GPUs. It allows developers and researchers to write code in familiar programming languages like C++ or Python, then leverage NVIDIA's graphics processors for massively parallel non-graphics computational tasks. As one industry analyst explained, CUDA made it vastly more accessible for engineers, researchers, and scientists to harness GPU acceleration for their work without needing to become graphics programming experts. But here's the critical detail that explains NVIDIA's dominance. They released CUDA way back in 2007. That's almost 2 decades of continuous development, documentation, optimization, and ecosystem building. Because CUDA launched so early and received consistent, unwavering support throughout the entire AI research community, it became the absolute default standard. NVIDIA cemented their position as the preferred GPU provider not primarily because their hardware was superior, though it was excellent, but because of the comprehensive software ecosystem they built around that hardware. While AMD was engaged in brutal competition with Intel over CPU market share and focusing on dominating console gaming and non-PC GPU markets, NVIDIA was operating on a completely different strategic wavelength. They were investing heavily in something that seemed almost futuristic at the time: artificial intelligence and deep learning. In NVIDIA's 2016 shareholder report, years before ChatGPT, Claude, or any consumer-facing large language models existed, they boldly stated that deep learning breakthroughs had sparked an AI revolution where progress was exponential, adoption was exponential, and the impact on both the tech industry and society would also be exponential. This wasn't marketing hype. This was strategic vision that would prove remarkably prescient. NVIDIA was already releasing GPUs specifically architected for AI and deep learning workloads, like their Tesla P100 series featuring Pascal architecture, at a time when most people still thought of GPUs primarily as graphics cards for gaming. So by the time artificial intelligence began demonstrating its genuine transformative potential, researchers and companies needed powerful GPUs in massive quantities, and there was really only one established option with proven software support: NVIDIA. At the very start of the AI boom, AMD actually did see a substantial revenue jump. Their total revenue skyrocketed from $9.7 billion in 2020 to $23 billion in 2022. It looked like AMD might finally get their chance to compete meaningfully in this explosive new market, but then something revealing happened. Their revenue dropped significantly the following year, and their profit numbers told an even more alarming story. 2021 represented AMD's most profitable year in company history, generating $3.7 billion in profit. But then things took a dramatic nosedive, plummeting back down to just $1.2 billion the following year. This is when the AI research community came to a collective realization. AMD wasn't the answer for serious AI workloads. Nvidia was the far better choice, not only for the physical chip hardware, but also for the mature software architecture backed by many years of prior research and optimization. AMD's market share began steadily slipping as Nvidia's grip tightened. When something becomes the entrenched standard for technological progress, disrupting that status quo becomes extraordinarily difficult. Things continued deteriorating for AMD, with profits falling again to only $600 million in 2023. There was absolutely no doubt AMD had fallen catastrophically behind in the AI race. To be completely fair, AMD had invested significantly in cloud computing infrastructure and data center hardware, but they hadn't invested nearly enough in machine learning specific capabilities. AMD desperately needed to catch up, and they knew it. So in early 2022, AMD made a bold move and acquired Xilinx, a company specializing in FPGAs and adaptive computing chips, for an absolutely staggering $49 billion. This represented the largest semiconductor acquisition in history at that time. But AMD didn't have $50 billion in cash reserves sitting around. Instead, they executed what's called a stock transaction, where Xilinx shareholders received millions of AMD shares in exchange for their company. This created an immediate problem for AMD's existing investors. The massive dilution of shares combined with uncertainty about the acquisition's value sent investor confidence plummeting. AMD's stock price, which had reached as high as $143 at the end of 2021, tumbled all the way down to just $84 by August 2022. But AMD pushed forward anyway. On October 10th, they acquired Nod.ai, an open-source AI software provider. The acquisition price wasn't publicly disclosed, but the strategic reason was crystal clear. AMD was attempting to rapidly catch up to Nvidia's massive lead. They were essentially betting the entire company's future on successfully competing in AI infrastructure. Even by early 2025, it seemed like everything was getting progressively worse for AMD as they continued losing market share ground to Nvidia's tightening grip. Many analysts openly questioned whether AMD could ever realistically catch up to Nvidia's enormous advantages, and more fundamentally, could they ever bridge the massive competitive moat created by CUDA's software ecosystem dominance? AMD needed a breakthrough, and they needed it desperately. Their answer came in the form of the MI300X, and to AMD's credit, they came out swinging aggressively. These were GPUs specifically architected from the ground up for AI workloads. The MI300X featured objectively better memory bandwidth and AI inference capabilities than Nvidia's flagship H100, which was the industry standard at the time. AMD's chip delivered memory bandwidth of 5.3 terabytes per second, approximately 60% more than Nvidia's H100. For AI and large language model tasks specifically, AMD also achieved a 40% latency improvement over comparable Nvidia hardware. But what does all this technical specification superiority actually mean in practical terms? Lower operational cost while maintaining equivalent output quality. AMD had successfully nailed one critical metric: cost per token generated with the MI300X. At lower batch sizes, AMD wins on cost efficiency. In mid-range batch processing, Nvidia offers slightly lower costs. But at higher batch sizes, AMD's MI300X wins decisively again. The more inference requests you group together for processing, the cheaper each individual request becomes, and AMD proved considerably cheaper at that large-scale processing. That cost advantage matters enormously for companies like OpenAI that process millions or tens of millions of queries continuously around the clock. They can serve substantially more users or train models faster for significantly less money. This represented AMD's genuine chance at finally re-entering the competitive game and potentially catching up to Nvidia's dominant position. AMD was pouring billions of dollars into AI infrastructure, new chip designs, new software architecture, strategic acquisitions across the board, lots of aggressive moves. But what actually resulted from all that investment? AMD quickly secured some impressive customers, including Microsoft, Dell, and Meta, who committed to using the MI300 series for AI training workloads. Industry anticipation was genuinely massive. But things didn't play out as everyone expected. The MI300 series was initially projected by analysts to generate approximately $8 billion in revenue. Pretty quickly, those projections were revised downward to $5 billion. Then the actual 2024 results came in. $5 billion total from Instinct Accelerator revenue. But that figure wasn't just the MI300X alone. That represented all Instinct product revenue combined. Despite the enormous hype and substantial investment, AMD's big answer for AI computing seemed to be fizzling out disappointingly. Investors and industry analysts weren't particularly impressed. HSBC analyst Frank Lee stated bluntly that they now believed AMD's AI GPU roadmap was less competitive than previously anticipated, and therefore AMD wouldn't be able to penetrate the AI GPU market as significantly as they had earlier projected. It was a brutally honest assessment of AMD's struggles. AMD had also developed their own software platform called ROCm as a direct competitor to CUDA. ROCm was genuinely good, and AMD even made it open source to encourage adoption and community-driven iteration. Developers found it was highly flexible and could work with existing infrastructure, but it was still competing directly against CUDA's massive established ecosystem. CUDA was typically easier to deploy straight out of the box with extensive documentation, representing simplicity versus ROCm's newer flexibility. Because of this fundamental difference, many developers and companies remained hesitant to jump onto the AMD platform regardless of potential cost savings or efficiency advantages. The switching costs seemed too high. It was an extremely tough period for AMD. CEO Lisa Su was desperately trying to catch up simultaneously to both Nvidia's technical lead and her own investors' sky-high expectations. One analyst remarked that while they applauded the progress AMD made with MI Instinct, growing a roughly $4 billion AI business from essentially nothing in just 12 months, unfortunately, investor expectations remained persistently out of reach. But AMD kept working, and then something happened that changed absolutely everything. While not everyone immediately jumped onto AMD's platform, there was one compelling reason for major customers to seriously consider them. Nvidia's market dominance created severe supply constraints. The H100 and H200, despite becoming a generation old, were still selling out completely. Many customers faced huge wait times to actually get their hands on Nvidia GPUs. Then, in late 2024, Vultr, a significant cloud infrastructure provider, announced a partnership with AMD to offer Instinct MI300X GPUs on their cloud platform. This mattered enormously because AMD's fundamental problem wasn't chip power or memory capacity anymore. It was adoption and accessibility. Vultr created a new public platform where developers could actually deploy and test applications on AMD's latest architecture without massive upfront hardware investments. But then came the announcement that truly changed everything. On June 12, 2025, at AMD's Advancing AI event, they revealed the upcoming Instinct MI350 series and, even more significantly, hinted at the next generation MI400 and MI450 chips. But there was something distinctly different about this announcement. Someone had been helping AMD design the fundamental architecture. Who? OpenAI. And that wasn't all. Someone from OpenAI actually took the stage to speak at AMD's event, which was unprecedented. OpenAI had played a substantial part in designing the next generation of Instinct hardware. AMD executive Forrest Norrod stated that OpenAI had given them extensive feedback that heavily informed their chip design decisions. Then, just months later, came the bombshell announcement. OpenAI's next-generation AI infrastructure will run on AMD Instinct GPUs, starting with the MI450 series launching in the second half of 2026 and extending well beyond. The deployments will be absolutely massive, potentially bringing in tens of billions of dollars for AMD. Some estimates suggest the deal could eventually reach $100 billion in total value. That's it for today, folks. See you in the next video.